In this series of videos, we're going to look a little more closely at SQL, specifically about querying the database and getting a little deeper into these queries so that we can do some more advanced things with them. So let's take a look a little bit deeper at the SQL select statement, and in particular looking at adding more complex conditions to our SQL so that we can do some additional things. So if we recall, the select statement has a where clause, and with that where clause we can add conditional statements to it. So you might add something if you're looking at a numeric comparison like this, where your select star from employees where salary is greater than or equal to 5,000. And again, these examples are all from our HR database that I've provided to you. So you can directly try these and follow along with these examples. Another example is doing a string comparison. Notice the difference here that with a numeric comparison, you do not need the single quotes around it, but when you are comparing any kind of strings or any kind of text data, that needs to have quotation marks around it, single quotation marks. We can also do date comparisons, and this particular format is probably not going to work for us as well in MySQL, but this is a format that is used by Oracle. And I'll show you in an example video how to do date comparisons with MySQL. And finally, you can do null comparisons as well. Select star from employees where commission percent is null. And the reason that you cannot say equals null is because null literally means nothing. It means the absence of data. So there's nothing to compare equality to. So therefore, instead of equals, you have to say is, because truly there is nothing there. So if the commission percent is null, then there's nothing to compare to, but if it has a value there, then you could use equals. So we're looking for the null values, so you have to say is null. So we already know about equality conditions, but there are also inequalities that we can do where A is less than B, A is greater than B, less than or equal to B, or greater than or equal to B. And there's also not equals where you can either use the less than, greater than sign or the exclamation point equals operator. So either of these two are acceptable as not equals. So if you want to know if A does not equal to B, you can use either of these operations. We also have the ability in MySQL and other SQL syntaxes to do logical operations, so connecting more than one of these inequalities or equality operators that we just spoke about. You can do that through logical operators, and where two or more conditions hold at the same time. So it really returns the condition intersection where both of them are true at the same time. You have or, where any of the conditions hold. It's the union of the two. And then not negates the result of an expression. So when you start combining these expressions, you can come up with some more significant and more complex SQL statements. Here's an example of using and. All the conditions must be true, so we say select star from employees where salary is greater than or equal to 5,000 and the hire date is before December 1st, 1997. So both of those things must be true. They must have a salary greater than or equal to 5,000. Their hire date must also be before December 1st, 1997. Or means any of the conditions can be true. So when we're looking at this example, we have select star from employees where salary is under or equal to 5,000 or over or equal to 10,000. That means that the gap between 5,000 and 10,000 is not listed in this particular query in the result set. Here's another example of or. If you switch the signs on this, the salary is greater than or equal to 5,000 or the salary is less than or equal to 10,000, what do you get? Well, if you think about that, since any of the conditions can be true, anything greater than 5,000 would be true. So that would be, say, 12,000. A salary of 12,000 would make that condition hold true. Or a salary less than or equal to 10,000. A salary of, let's say, 4,000 would be true there. So what this is actually saying is the range of all salaries are possible in this query. So really the where clause doesn't do much for us. This is very important to remember because sometimes people get the signs flipped when they mean something like this and they instead add something like this. So it's very important for us to watch the symbols that we're using, especially when we're combining with ands and ors. So here's another example with not. So not negates the result of an expression. So if we have the same condition here, which says we can get anything, what does this give us? Well, this would give us nothing because it's negating the results here. So if this would give us anything, then this would give us nothing. And we have to remember that again when we are combining expressions like this. And just like order of arithmetic operations, there's also an order of logical operations. So not is evaluated first, and then or. And you can override the precedence, of course, using parentheses, but within the parentheses, the precedence is the default order, not and then or. So an example of that, show all employees who have a commission of 20% and either a salary less than or equal to 10,000 or has a manager ID of 100. So how would you do that? Select from employees where salary less than equal to 10,000 or manager ID equals 100. So that's in parentheses because that's a condition by itself. The other condition is commission percent equal to 20%. So that is anded, the stuff in parentheses is anded with the commission percent equal to 20% because that is also a separate condition. Another thing we can do with complex conditions in MySQL is string comparison. So in this case, we have the simple equality here where we say last name equals Taylor or last name equals Smith, and that will return us a list of all the people whose last name is one of those two things. Another thing you can do is simplify this and say, and this returns the same data. You can simplify this and say last name in and then give it a list of names. So Taylor, comma, Smith. And these two statements are equivalent so that there is really no difference there. But when you start having a long list of ors in a single statement, a long list of ors here. So let's assume we had 6 or 7 ors. That would be a long statement, but with the in keyword syntax, you could list all 6 or 7 within the parentheses and shorten the statement quite significantly. Now, let's go back and look again at our select statement syntax, and there is an option for grouping things together. And the group by statement, which I've highlighted here, is what we use to do that. So if you use any kind of function to aggregate data together in the select list, anything that is outside that expression, that aggregate function expression, has to be included in the group by. Remember, not necessarily all statements will have this type of syntax, but certainly if you use an aggregate function like sum or count, and then you include other columns or other parts of a select expression, then that must be part of the group by. So let's take a look at this particular group by. So let's create, and this is kind of using a string comparison by grouping the job IDs together. So every time it sees the same job ID, it's going to include that value for salary in an average. So it creates groups of job IDs and then finds the average of each of those groups. Without the group by, SQL does not know what groups that it should define. So in the second example, this does not require a group by because we do not have anything that is outside the aggregate functions, average and sum. So no grouping is required because the statement implies that you want the answers to be overall. You want the overall average salary for all employees in the IT program. And you want the overall sum of the salaries in the IT program job. So here's an example using the HR employees database, and it selects department ID and the average salary, and we're aliasing average salary. Then it's selecting from the employees table, group by department ID, and order by department ID ascending. So for each department ID, we will have the average salary for those employees. And when you run this, you should get something that looks like this. Notice that there is a value for each individual department ID that's listed in the employees table, and then an average salary for that department ID. So some of them have longer precision than others because it's not a clear-cut case. And there's also one that's null, and the department ID that's null means that that individual or set of individuals are not assigned to a department. Another thing that we need to be aware of is the having clause. The having clause is something that is required to compare to the result of an aggregate function. It's required to compare to the result of an aggregate function. The aggregate condition that is specified is a conditional statement that compares to the result of that aggregate function. So taking another look at this, if we were to do this and we wanted the display to show where the average salary is greater than or equal to 6,000, we cannot do that with a where clause. And the reason we cannot is having is kind of like a where clause, but having operates on the results of an aggregate query after that query has executed. Where, on the other hand, is not able to do that because it is comparing for each row that it encounters. So having waits until the end, whereas where is doing the comparisons continuously throughout the operation. The example on the right does not require a having clause because in this case we are not comparing to an aggregate function. We are comparing simply to a field in the table, and that field in that table is job ID. So for every row that we want to compare to, we're just checking to see if job ID is equal to IT programming. Here's a more concrete example of having, and you notice that we have department ID and the average salary. Again, from the employees table, we're grouping on a department ID, and it says having average salary greater than or equal to 10,000. So notice that there are only 3 of those, so 70, 90, and 110. And if we went back to look at the previous one, at the previous example here, if we look through here, 70, 90, and 110. So if we compare those to our query here, the having clause is doing this job for us. So there are some very complex condition operators that we can use in SQL to get some really good results back. So the next video, I'm just going to go through a set of examples where you can see me actually typing this into MySQL and doing some comparisons that way.